and beautiful topic in quant, which is time and distance. So when I say most interesting, it's also the most important topic, because as far as any competitive exam is considered, so this time and distance plays a vital role. You might get even a very easy question in time and distance or a very difficult question. But is the concept difficult? No, it's actually the simplest concept. The only one formula which you should know, which you probably know, is distance is the product of speed and time. Okay, will I get questions only based on this formula? In a way, yes, but how to extend this formula? What does this formula mean? What is the concept behind this formula? And what is the logic? And how the questions can be framed? What different questions are possible? We'll be seeing it one by one. Let's get into the chapter, time and distance. Okay. When I say the only one formula in this is distance equals speed into time. Okay. When I say this is the only formula, see, we do have some other formulae as well, but those are all the extension of this formula. If you can just understand what is this and why is it the product, and when one parameter increases, how are the other parameters behaving, you can just extend the same formula. Okay, let's say distance equals speed into time. So we denote as d equals s into t. Now let's take a live example. The most important thing which you should assume here is, say, speed. So what is speed? Say we travel at 60 kilometers per hour. Okay, so if I travel at 60 kilometers per hour, I'm saying, okay, is it, say I'm traveling a distance of 60 kilometers, I travel at 60 kilometers per hour, and the time taken will be 1 hour. Yes, because 60 equals 60 into 1. Okay, now the distance is 60, no issues, no problem here. The time is 1 hour, no problem. But when I come to this parameter speed, when I say speed is 60 kilometers per hour, what does that mean? Will I start my bike or a vehicle at 60 kilometers per hour and go non-stop at 60 kilometers per hour? No, that is not practically possible. But why are we saying it as 60 and 1 hour when the distance is 60 kilometers, and when I travel for 1 hour, the speed is 60 kilometers per hour? This is the average speed here. So I cannot say the 60 kilometers per hour is the only speed in which I travel. Say I'll start at 0, I'll go to 10 it will reach at 10 kilometers per hour, then 20, then 30, it will cross 60. For some distance I might even travel at 80. There will be speed breakers in between. I'll come to 30 or even give a pause. So put together, the time taken for me to travel a distance of 60 kilometers is 1 hour. That is why the speed is 60 kilometers per hour. So when I say speed, it is considered as the average speed. So whenever I say I travel 60 kilometers per hour, the assumption here is throughout the entire duration, I am traveling at 60 kilometers per hour. Okay, practically, which is not possible. That is why I'm using the word average speed here. But speed and average speed, when I say speed, it is the average speed. Let's get into the average speed concept in the next slide. Now let's understand this. So 60 kilometer distance, I travel at 60 kilometers per hour, I'll travel in 1 hour. Now I have three parameters: distance, speed and time. Let's see how these parameters are behaving. Now let's fix the distance as 60 kilometer. Okay, so the distance is 60 kilometer, that is fixed. Now I'm just increasing the speed. Now if the speed is 120 kilometers per hour, so when the distance is constant, if the speed is increasing, what will the time, will it increase or decrease? The same distance 60, if I'm traveling at 60 kilometers per hour, I'll reach in 1 hour. If I travel at 120 kilometers per hour, it should decrease. So this will be half an hour. So I'll reach the destination in 30 minutes. So for a constant distance, if speed is increased, time will decrease. Similarly, for the same distance, if I decrease the speed, say 30 kilometers per hour, what will the time? Same distance, 60 kilometer, I'm going at a lesser pace, lesser speed. Okay, so 30 kilometers per hour. So I'll take more time. So time should increase, which is 2 hours. So for a constant distance, when speed is increasing, time will decrease, and when speed is decreasing, time should increase. So they are behaving in the opposite way. So when this parameter increases, this parameter will decrease. When this parameter decreases, this parameter will increase. Therefore, can I say speed and time are inversely proportional to each other? Yes, so speed and time are inversely proportional. Now, let's fix the other parameter. Let's say speed is fixed, say 60. This is my initial case. Okay, so I'll just fix this. So So now speed is fixed. So speed is 60 kilometers per hour. Now I have to travel only 60 kilometers per hour. If I'm traveling 120 kilometer, now the distance is increased. So what will be the time? So for a constant speed, if the distance is increased, the time will increase. So 60 kilometer per hour is the speed. If I have to travel 60 kilometers, I'll take 1 hour. If I travel 120 kilometers, I will take 2 hours. So for a constant speed, when the distance increases, time will definitely increase. Now let's fix the same speed. If I decrease the distance, so when the distance decreases, let's say 30 kilometers, what will happen to time? It will also decrease because I have to travel only 30 kilometers at the same speed. I'll take only 30 minutes. So now can I compare distance and time? For a constant speed, distance is directly proportional to time. So here distance is directly proportional to time. So here speed is inversely proportional to time. Okay, so when I say proportional, there will be some constant. So here d is the constant, here s is the constant. Okay, now let's fix time. Now time is fixed, say 1 hour. Now I have to travel only for 1 hour. Okay, now I am decreasing the distance. When distance is decreased from 60 to 30, what will happen to my speed? Speed should also decrease. If I increase the, for a fixed time, if I increase the distance, when distance is increased to 120 kilometers, speed should also increase because I have a time limit of only 1 hour. I have to travel 120 kilometers, my speed will increase. So when in this case, for a constant time, distance is directly proportional to speed when time is constant. Okay, so we have three parameters: distance, speed and time. All these three parameters are interrelated. So whenever I say proportion, there should be some constant. When I'm relating two parameters, I can relate two parameters, I can compare two parameters only when the third parameters are constant. I cannot compare by increasing the speed and decreasing the distance and decreasing the time. No, I cannot compare like that. So one parameter should be fixed. Okay, now, so summarizing this, distance is directly proportional to speed at a constant time. Next, distance is directly proportional to time at a constant speed. Then we have speed inversely proportional to time at a constant distance. Therefore, the formula is distance equals speed into time. Now, what is the unit we use to measure distance and speed and time? In general, we have kilometers. Speed is kilometers per hour. Time should be in hour. So when I say distance is is measured in kilometers, speed in kilometers per hour, time will be in hours, or it can be meters per second. So when the distance is in meter, speed is in meters per second, time will be in seconds. Okay, so when this is kilometer, speed will be in kilometer per hour into hour, time should be in hours, or meters, meter per second and seconds. Now what is the conversion? See, kilometer per hour, if you have to convert to meters per second, 1 kilometer is equivalent to 1000 meters. 1 hour is equivalent to 3600 seconds. So we cancel, we'll have 10 by 36, which is 5 by 18. So kilometer per hour equals 5 by 18 meters per second. 1 kilometer per hour is equivalent to 5 upon 18 meters per second. Say if I have, for an example, if I say 54 kilometers per hour, how will I calculate? 54 kilometers per hour is nothing but 5 by 18 times 54. So 18 times 3 is 54. So 5 into 3, 15. So 54 kilometers per hour is equivalent to 15 meters per second. So this is the conversion for kilometer per hour to meters per second. Same thing in reverse. If I have to convert a meter per second to kilometers per hour, I should multiply by 18 by 5. Okay, so this is the conversion. Need not memorize, just remember this. So kilometer to meter, so meter is the smaller quantity, so I should multiply by 5 by 18. Meter to kilometer, kilometer is the greater quantity, so I'll multiply by 18 by 5. In simpler words, if you have to memorize, you can just remember this. So kilometer per hour to meters per second, multiply by 2 meter, so 2 smaller unit, so I should multiply by 5 upon 18. Meters per second to kilometer per hour to a greater unit, I should multiply by 18 by 5. Now, let's get into the next concept, which is average speed. As I already said, What is average speed? The distance by time. Okay. Now, what is the difference between average speed and average of the speeds? Okay, there are two terms: average speed and average of the speeds. Average of is nothing but just the number. Say if I have a speed of say 10 kilometers and 20 kilometers per hour, average of is 10 plus 20 divided by 2. So average of is nothing but average of the numbers. But when I say average speed, it is the total distance traveled divided by total time taken. As I said, I have a distance of 60 kilometers. I am taking 1 hour. Okay, so what is my average speed? It is 60 kilometers per hour. Okay, so but did I travel the entire distance in 60 kilometers per hour? No, I could have traveled in 30 or 35 or 65 or 60, any speed. But the average speed here is 60 kilometers per hour. That is the meaning. So the formula for average speed is total distance by total time. Let's take an example. So let's take a distance AB. Let's say the distance is x kilometers. Okay, a person is traveling from A to B at a speed s1. Say a person is traveling from A to B at a speed s1 and returning from B to A at another speed s2. Okay, so a person is traveling from A to B at a speed s1 and returning from B to A at another speed s2. What is the average speed of the entire duration? For the entire duration. Okay, what is the average speed? As we all know, what is average speed? Total distance divided by total time. Here, what is the total distance traveled by the person? He travels from A to B and then from B to A. So A to B and B to A. So total distance is x plus x. So total distance is 2x divided by total time. So what is the total time? Time taken by the person to travel from A to B plus time taken by the person travel from B to A. So onward time and return time. Okay, so from A to B I'll have time say T1, return time is T2. So we know average speed is total distance by total time. What is total distance? X plus x. Total time, let's say T1 is the onward time and T2 is the return time. Okay, so x plus x divided by T1 plus T2. Now what is T1? Distance by speed. So onward distance, which is x kilometers, divided by the onward speed, which is s1. So x plus x, 2x divided by t1 plus t2. T1 is nothing but x by s1 and t2 will be x by s2. So hence the average speed is 2x divided by x by s1 plus x by x2 s2. So I can cancel out x in the numerator and denominator. So you'll have 2 divided by 1 by s1 plus 1 by s2, which is nothing but 2 divided by s1 plus s2 by s1 s2, which is equivalent to 2 s1 s2 by s1 plus s2. So this is the average speed. Let's take an example. So let's say the distance is 100 kilometers. Okay, so the distance between A and B is equal to 100 kilometers. Speed s1, a person travels from A to B at a speed of 40 kilometers per hour and return speed is 60 kilometers per hour. Now what is the average speed? Total distance by total time. Total distance 100 plus 100, 200 divided by total time 100 by 40 plus 100 by 60. I can simplify that, or I have the formula which is 2 s1 s2 by s1 plus s2. Is it dependent on the distance? No, because the distance here is the same. So this distance will anyways, it will cancel out each other. So when I say average speed for the same distance, I'm going and coming, only for that you have to use this formula, which is 2 s1 by 2 s1 s2 by s1 plus s2. So 2 into 40 into 60 divided by 40 plus 60. So 2 into 40 into 60 divided by 100, which is 2 into 4 into 6, which is nothing but 48 kilometers per hour. Hence the average speed is 48 kilometers per hour. See, it is not 50. 40 plus 60 by 2 is the average of. So here it is not just adding the numbers and dividing by 2. Okay, this is the average speed, which is total distance by total time. Always remember, they will never ask you to find the average of the numbers or average of the speeds. It's always the average speed. Be careful when you see the term. It is not just the sum. It is the total distance divided by total time. You know what is total distance? 100 plus 100. Here the distance is same, hence x plus x divided by x by s1 plus x by x2 will cancel out each other. If the distance is different, say A to B and then B to C, the average speed will be not have this formula, because there I'll have 100, say I'm traveling a distance of 140 and the next distance of 200 at 60. Okay, so let's say I'm traveling a distance of 100 at 40 and the next distance is 200 at 60. So all the formula change. I'll have 100 plus 200, which is 300 divided by 100 by 40, 100 by 40 plus 200 by 60. So here only this hundreds will cancel. The final answer formula will be 3 divided by 1 by 40 plus 1 by 60. 3 divided by 1 by 40 plus 2 by 60. 2 by 60 is 1 by 30. So 30 plus 40 will be 70. So 30 into 40. So 3 into 30 into 40, which is 1200 divided by 70. This will be your final answer. Got it? So here it is not the formula to S1 S2 by S1 plus S2 because the distance is not the same. Right? Now let's move on to the next concept, which is the relative speed. Okay. Now what do you mean by relative speed when I say? Let's see. A person travels from A to B at a speed S1. Okay. Another person from B to A at a speed S2. Okay. Now a person is traveling from A to B at a speed S1 and another person from B to A at a speed S2. The distance between A and B is S. Now when I say relative speed, it's the sum of the speeds because they are traveling in opposite directions. Why? Let's take an example. Let's say the distance between AB is 100 kilometer, okay, and S1 is 30 kilometers per hour, S2 is 20 kilometers per hour. So two people, one at traveling from A to B at 30 kilometers per hour, another person traveling from B to A at 20 kilometers per hour. Now after how many hours will they meet when if they start at the same time? Okay, so they're starting at the same time at two different points. They're moving towards each other. After how many hours will they meet? Okay, if we think of the logic here, 100 kilometers they should travel together. That is the meaning, right? So a person travels from A. So I'm coming from one point, you are coming from the opposite side. So we are meeting. I am traveling at 30 kilometers per hour. You are traveling at 20 kilometers per hour. So after 1 hour, I would have traveled 30. After 1 hour, you would have traveled 20, right? So but the total distance traveled by us in the first hour is 50, but we have to travel 100. So in 2 hours I will travel 60, you would have traveled 40. Therefore in 2 hours we will meet. So here the relative speed, since two people are coming in opposite directions, it's the effective, so it's 50 kilometers per hour because the same time I'm traveling 30, you are traveling 20, we both together travel 50 kilometers. So for every hour, the distance between us is reducing by 50 kilometers. It should become 100. So when the distance is reducing by 50, 50, when it is 0, so which means when we both travel a distance of 100 kilometers, we will meet. So in 2 hours, we will meet. So the relative speed here is 30 plus 20, which is 50 kilometers per hour. Time taken by us to meet is 100 kilometers divided by 50 kilometers per hour, which is 2 hours. In 2 hours, we will meet. Now, what if they travel in the same direction? Say, I am at point A. Let's take the same distance, A and B. Say a person is starting from A, person is starting from B. They're traveling the same direction. Okay. So, a person at B is traveling to, so the distance is 100. A person is traveling from A towards B, I mean to the right. Another person at speed S1. The second person is traveling from B again to the right. Say the point B, C. So both of them are traveling towards C, the same direction. Okay. So B is running from B to C. A is running from A to C. So A should cross B. It's a linear path. Okay. Now, so for my A to catch B, A should be faster than B. So A speed should be greater than B speed. If B is traveling at 10 kilometers per hour and A is also traveling at 10 kilometers per hour, will A be able to catch B? Not possible. So A should be faster than B to catch. Now, let's say the same speed. Say A is at, I mean the person at A is traveling at 30 kilometers per hour like the previous case and S2 is 20 kilometers per hour. Now, will A be able to catch B? Yes, possible. And the condition here is they start at the same time. Okay. Now A and B are starting at the same time. Remember that. Now B is running at 20 kilometers per hour. A is running at 30 kilometers per hour. Now, if A is running at 20 kilometers per hour, he will not be able to catch. Since A is running at 30 kilometers per hour, he will be able to catch. So the extra speed makes the difference. So here, what extra speed, what additional speed A is traveling than B? It's 10 kilometers per hour. A is 10 kilometers per hour faster than B. So for every hour, the distance between them will reduce by 10 kilometers. Say two people are at this point, this distance is 100. When he travels 20, let's take the point A is 0 and B is 100. So let's take in a number line. So this point is 0. Okay, this point is 100. After 1 hour, A will have traveled 30. So A will be here at 30. B will be at 120. So what is the distance between A and B now? It is 90. See, for 1 hour, the distance between them is reducing by 10 kilometers. So when the distance between them is 0 kilometers, they would have met. Now, so after 1 hour, the distance, so after 2 hours, he'll be at 60, he will be at 140. So the difference between 60 and 140 is 80. See, for every hour it's reducing by 10, 10, 10. So after how many hours will it be 0? I have a total of 100. So every hour it is 10. So 100 divided by 10 in 10 hours. So in 10 hours A will catch B. So if I am saying they are meeting at C, right? So after 10 hours both of them will be at this particular point. So 10 hours he would have traveled how much? 200. He would have traveled 300. So this distance should be 100, which is actually given as 100. Got it? So therefore they will meet at this point C. Now here what is the relative speed? Since they are traveling the same direction, the relative speed is nothing but S1 minus S2. So 30 minus 20, which is 10 kilometers per hour. So time taken by them to meet will be 10 hours, which is 100 kilometers divided by the relative speed. See, the formula is the same, distance by speed. But here for the distance, you have to take the distance. For speed, it is the relative speed or the average speed. So here it is relative because two people are traveling. It is not average. Okay, so time taken when they travel in the opposite direction will be 100. Distance is always added, so distance divided by sum of the speeds. So opposite directions, same direction, distance divided by difference of the speed, so that he will catch. So after 10 hours he will meet. What is the distance between B and C? It has to be 200. Okay, now let's look at the same way in circular path. Now say a circular path, the distance is 100 kilometers. A circular track, the distance is 100 kilometers. Okay, now a person is traveling from A in clockwise direction and another person is traveling from the same point B. Say two people, say A and B are two different people. So A is traveling clockwise and B is traveling anti-clockwise. The speed of A is 20 kilometers per hour. The speed of B will be 30 kilometers per hour. After how many hours will they meet? Okay, they're traveling in opposite directions. Okay, so A is traveling this direction, B is traveling in this direction. So when they travel in opposite directions, right, so the relative speed will always be sum of the speeds, because for every 1 hour A would have traveled 20, B would have traveled 30, but they should travel 100 for them to meet. So in 2 hours A would have traveled 40, B would have traveled 60, therefore they would have met at some point. So after 2 hours they will meet for the first time. So here the formula is nothing but simple, which is 100 divided by sum of the speed. So distance divided by sum of the speeds, which is nothing but 50. Hence in 2 hours they will meet. What if they travel in the same direction? Same concept, same logic. So you have A and B, two people. A 20 kilometers per hour, A speed is 20 kilometers per hour, B speed is 30 kilometers per hour. Both of them are traveling in the same direction. Okay, now 100. So time taken to meet for the first time will be 100 divided by 10, which is 10 hours, because when A has traveled 30, B would have, I mean, when A has traveled 20, B would have traveled 30. So B is actually ahead. Now for B to catch A, B should travel one extra circle than A. So wherever they are meeting, when A has covered some number of circles, B would have traveled one extra circle. So B is in front. So when they are running clockwise, so when B catches A, wherever be the point, B has traveled one more circle than A. Okay, they'll meet at any point. So B should travel one more circle. So B should travel 100 kilometers more than A. So what is the extra distance B should travel? 100 kilometers. Now at what speed? The extra speed which will help him to travel the extra distance. So 20 will be the same. Now 20 the difference is 10. That is why 100 divided by 10. So again the concept here is the formula will be 100 divided by 30 minus 20 relative speed, which is the difference since they travel in the same direction. Okay. Now let's take three people. Okay. So A, B, C. So there is a point, fixed point. All three people started running. Now A is traveling in clockwise direction. B and C are in anti-clockwise direction. So A is traveling in one direction. B and C are traveling the other direction. Okay. Now A speed is 20 kilometers per hour. B speed is 30 kilometers per hour. And let's say C speed be 10 kilometers per hour. Okay. Now A is traveling clockwise 20 kilometers per hour. B is traveling anti-clockwise 30 kilometers per hour. C is also traveling in the same direction as B at 10 kilometers per hour. What is the time taken by them to meet for the first time? Okay, what is the time taken by them to meet for the first time? Okay, when will they meet for the first time? Now, so for all three to meet, first let's say A and B are meeting. So when will A and B meet? What is the distance? Let's say the distance is 100 kilometers. Okay. So 100 kilometers, A and B will meet after 2 hours. So for, can I say, for every 2 hours A will keep meeting. So first meeting will happen after 2 hours. So after meeting, still B has to travel one extra circle. So for every 2 hours, so 100 divided by opposite direction, which is 30 plus 20. I'm just looking at A and B alone. So 30 plus 20 will be 50. 100 by 50 is 2 hours. So for every 2 hours, A and B will meet. If they're starting at 12 o'clock, 2 o'clock, 4 o'clock, 6 o'clock, 8 o'clock, 10 o'clock, 12 o'clock, 2, 4, 6, 8, 10, they'll keep on meeting at that time. Right? Now, A and B will meet every 2 hours. Now, let's say B and C. So, B and C will meet after how many hours? B and C are traveling the same direction. So, 100 divided by 30 minus 10. Okay, so 100 divided by 30 minus 10, which is 20. So, 100 by 20 is 5 hours. So, B and C will meet after every 5 hours. A and B will meet after every 2 hours. B and C will meet after every 5 hours. Let's say time 0. Okay, so A, B will meet 2, 4, 6, 8, 10, 12, 14, 16, 20, 18, 20, 22 and so on. B and C will meet 5, 10, 15, 20, 25, 30, 35, 40 and so on. Now, when will they both meet? So I have to find the common number which is common to both. So A and B, let's take, say A and B will meet at, say, 0. So they're starting at 0. So after 0, 2, 4, 6, 8, 10, 12 and so on. Now B and C start at 0. After 0, 5, 10, 15, 20 and so on. Now all these three to meet, AB and BC, which is nothing but ABC. So the first starting point 0 at this point. Now after that, when is the first time? After 10 hours, because 10 is common to both the terms. So at 10 hours or after 10 hours from the start, they will meet for the first time. Got it? After this, for every 10 hours they will meet. So here 20, yes. So 10 for every 10 hours they will meet. Now what is the concept here? We have 0, 10. So which is nothing but the time taken by A and B to meet and the time taken by B and C to meet, which is this. So I'm finding the LCM. So A and B will meet after 2 hours. B and C will meet after 5 hours. So what is the LCM of 2 and 5? 10 hours. So after 10 hours, all three will meet. Okay, so we have the formula. Time taken to meet for the first time is nothing but LCM of the time taken to meet in pairs. So A and B, B and C, or you can even have A and B and A and C. The answer will not change. So A and B will be 100 divided by 30 plus 20. A and C will be 100 divided by 20 plus 10. So 100 by 50, 100 by 30. In that case, still LCM of the fractions is nothing but LCM of the numerator divided by HCF of the denominator. So numerator is same, 100 divided by HCF of the denominator. Here it will be 50 comma 20, which is 10. In the other case, if I say AB and AC, it will be 50 comma 30. 50 comma 30 is still 10 HCF. So hence the time taken by them to meet will be the same, which is 10 hours. So all three will meet for the first time after 10 hours. Okay, now let's say all three are traveling in the same direction. So the distance is 100 kilometers. Now A, B, C, they start at the same point. A is traveling in clockwise direction at speed of 20 kilometers per hour. B is also traveling the same direction at speed of 30. C is also traveling the same direction at speed of 10 kilometers per hour. After how many hours will they meet? So same thing, all are traveling the same direction. So here LCM of the, so let's say AB then AC. So AB will be 100 divided by 30 minus 10. AC will be 20 minus 10. BC will be 30 minus 10. So you can take any two, ABAC or ABBC or either ABAC or ABBC. Okay, take any common number. Okay, now if I say AB and 30 minus 20, I am taking AB and BC. So 100 divided by 30 minus 20, comma 100 divided by 30 minus 10. So LCM of the fractions is LCM of the numerator divided by HCF of the denominators. Okay, so I'll have 100 by, or you can simplify and get, but in case if you get a, if you're not getting a whole number value, say in the previous case when we take 30, say 20 and 10, 20 plus 10 will be 30. So if I have 30, if I cancel 100 by 30, it is 3.33. So that becomes a bit tedious to find the LCM. But still, if you just have it as a fraction and play with the fraction, it is easy. So numerator is the same, so 100 it will not affect, divided by, just find the HCF of the differences. Okay, so same direction, 30 minus 20, 20 minus 10 or 30 minus 10. So it will still be 10. So 100 divided by 10 will be 10 hours. So time taken by all the three to meet for the first time will still be 10 hours, even in the first case and in the second case. Will the number 10 hours be always the same? No. For this problem, because I took an easy number so that you can understand, here it is 10 hours. It need not necessarily be the same. Okay. Now, what if the question is time taken by them to meet for the first time at the starting point? Okay. See here, this 10 hours is the time taken by them to meet for the first time ever. Okay, so A and B, first time ever. If we just say two people, they have to meet for the first time ever, right? Then we know same direction, distance by sum of difference of the speeds. Opposite direction, distance by sum of the speeds. When I say they have to meet for the first time at the starting point, after they start, so they start at the same time, right? They keep on running the respective directions. They have to meet at the starting point again, both of them. So after how many minutes? So in that case, what is the logic? So let's take two people alone, say A and B alone. Okay, now let's forget about C. So let's say A and B. A in this direction, B in this direction. First time at the starting point. Okay, so A will come to the starting point for every 5 hours. So because distance is 120 km per hour, A will be at the starting point for every 5 hours. B will be at the starting point for every 100 by 30, which is 3.33 hours. Okay, B will be the starting point for every 3.33 hours. Let me see C as well. C will be the starting point for every 10 hours. Okay, so whichever direction they travel, they'll come to a starting point in their respective times, which is 5, 3.33 and 10. Okay, now time taken by them to meet for the first time, the starting point is nothing but LCM of the time taken. So 5, 3.33 and 10, which is the LCM, which is nothing but 10. So 10 hours. So multiple of 5, multiple of 3.33 and multiple of 10, which is the least common multiple, which is 10. Right. So time taken by them to meet for the first time at the starting point is nothing but LCM of the time taken. So here I won't say whether they travel in same direction or opposite direction. It doesn't matter. So when the question is time taken to meet for the first time at the starting point. So this term is important. Starting point. That is nothing but just the LCM of the individual time taken. It doesn't matter whichever direction they travel. But if the question is time taken by them to meet for the first time, then the direction is important. Same direction, difference of the speeds. Opposite direction, sum of the speeds. So here it will be LCM of individual time, which is the distance, which is 100 divided by individual speeds, say 20, 30, 40. So which is nothing but LCM of the numerator, which is the distance, divided by HCF of the speeds. So here the HCF of the speeds is nothing but 10. 10, 20, 30 is 10. So it will have 10 hours. So simple. Just I'll give some 30 seconds to 1 minute for you to understand this. Just look at the slide for a minute and just visualize and think. Just recollect whatever I said. Okay, shall we move on to the next part? Now let's get into the questions. So we have the very first question. You have the handout in front. So here you have to just convert the following speeds into kilometer per hour. You know what is the conversion formula? Meters per second to kilometer per hour. So to kilometer, which is the higher unit, so I should multiply by 18 by 5. So 5, if I cancel, I'll have 3. So 3 times 18 is nothing but 54. Similarly, second question will have 37 by 72. So 37 divided by 72. So meters per second to kilometer per hour. So into 18 by 5. Just cancel. I'll have 18 times 4 will be 72. So 4 into 5 will be 20. So our answer is nothing but 37 divided by 20 kilometers per hour, which is 3.7 divided by 2. So 37 by 2 is 18.5. So 3.7 by 2 will be 1.85. Hence our answer will be 1.85 kilometers per hour. So simple conversion. You have the unit. So meter per second to kilometer per hour, 18 by 5. Kilometers per hour to meters per second, it has to be 5 by 18. Okay. Okay. Try this question. Traveling at 4/5 of the usual speed, a man is 15 minutes late. What is his usual time to cover the same distance? Okay. Traveling at 4/5 of the usual speed, a man is 15 minutes late. Okay, let's see. So we have distance, as I said, about only one formula. Distance equals speed into time, right? Now traveling at 4/5 of, so the actual initial distance is d, actual distance is d, actual speed is s, and the actual time be t. So d kilometers or some kilometers, speed in kilometer per hour, t in hours, right? Or meters per second. Let's say hours. So always have it in kilometers per hour and hours. Okay. So d in kilometers, s will be in kilometers per hour, time will be in hours. Okay. Now traveling at 4/5 of the usual speed. Now the speed is becoming 4 by 5s. A man is 15 minutes late. So if this is, so what is the usual time? So the distance is the same distance. Now d equals 4 by s. If this is 4 by s, I know d equals st. So when I replace d equals s into t, ss will cancel. So what will be t? It has to be 5 by 4 t. Okay, so the actual distance is speed into time. The new speed will be 4/5 of the original speed. So the time should become 5 by 4 times the original time. So that this 4 will cancel, 5 will cancel, d equals st will be true. So d equals s into t. So we have d when the speed is decreasing. See, when the speed is decreasing, time should increase. And that should be, since the distance is constant here, speed will become 4 by 5th. Time should become 5 by 4th. It is just the reciprocal. Right? Now, what is the question he says here? He's 15 minutes late. So the actual time is t, the newer time is 5 by 4 t. So what is the extra time he's checking? 1 by 4 t. So 5 by 4 t minus t, which is 1 by 4 t, is the extra time which is taking. This is given as 15 minutes. Therefore, what is t? 15 minutes into 4 is nothing but 60 minutes, which is equivalent to 1 hour. So the usual time will be 1 hour. What is usual time to cover the same distance? This is 1 hour. See, the only one formula you know, but this is decreasing. This has to increase. Okay, so when this is 4 by 5, this will become 5 by 4. So the increase is 1/4 of the time. So 1/4 of the time is given as 15 minutes. Hence we'll have t as 60 minutes, which is equivalent to 1 hour. Okay, this is the traditional way of writing the equations and doing. Without framing the equation, can you do this question mentally? Yes. Now, what is this here? You have two parameters constant. If you remember in percentages class, you have length into breadth is a constant. When one parameter increases, other parameter will decrease. Or price into consumption is expenditure. You remember that question? You have a model. Say when the price is increased by 20%, how much should the consumption be reduced so that the expenditure remains the same? Same concept here. So consider this as price. Consider this is consumption. Consider this is expenditure. So price into consumption is expenditure. It is nothing but A into B equal to C. The product of two terms is equal to the third term. The third term is a constant. Okay, so these two terms will be inversely proportional. So when the price increases, the consumption should reduce. So this is nothing but percentage increase and percentage decrease. So here S is becoming 4 by 5. So T will become 5 by 4. Or when the speed is reduced by 1/4, it's becoming 4/5, which means it is reduced by 1/5. So 20 percentage. If the speed is reduced by 20%, how much should the time increase? Time should increase by 25%. How we got this number? Price into consumption. When the price is decreasing by 20%, consumption should increase by 25%. Or the reverse. When the price is increasing, when this is decreasing, this should increase. Okay. What is the logic behind it? So let's say I have 4 apples. I have 5 apples with me. Okay, since the decrease is 20 percentage, or let's say I have 4 apples with me, let's say go from increase, so 4 apples with me, I'm increasing by 25%, so 1/4 increase. So now how many apples will I have? 5 apples. Now from 5, so I'm increasing 1 apple. Okay, now from 5 apples, if I have to get 4 apples, how much I should decrease? Same 1 apple, but the increase is 1 upon 4, the decrease is 1 upon 5. So the percentage increase and decrease is not the same. Hence, if I increase by 25%, I should decrease by 20%. So here the decrease is given. If I decrease by 20%, how much should I increase? So here, since it's becoming 4/5, it's decreased by 1/5. So I have 5 apples. Now it's decreasing. The formula is nothing but x by n increase, x by n plus x decrease. Forget about the formula, just get the concept here. So if I have 5, since I'm 1/5 decrease, so 4/5 of the speed is nothing but 1/5 decrease. The base is 5. If I have 5 apples, I'm decreasing 1 apple, I'll get 4 apple. From 4 to 5, how much should I increase? I should increase the same 1. So but 1 out of 4, so 1 out of 5. So when this decreases, this increases. Here decrease is given. So 1/5 decrease, 1/4 increase. So the increase is the other parameter. So here the time is increasing. So time should increase by 1/4, which is 15 minutes. So 1/4 of the time is actual time is 15 minutes is equal to 15 minutes. Hence the actual time will be 4 times 15, which will be 1 hour. Hence the answer. So whenever you get questions like this, since the distance is constant, you can just go with it. If the question is reverse, when the speed is increased by, say, a man is traveling at 7/6 of the speed. Let's say a man is traveling at 7/6 of the speed, usual speed. Okay, so instead of 4 by 5, I'm saying man is traveling at 7/6 of the usual speed. So he's actually increasing the speed. Therefore, the time will reduce. Therefore, he's early by, say, X minutes. Okay. Now, how much is the speed reduced? So 7/6 is nothing but 1/6 increase. Okay. So speed is increasing by 1/6. So I have 6 apples. If I'm increasing 1 apple, I'll have 7 apples. How much I should decrease? Same 1 out of 7. So the time will reduce by 1/7, since it will become 6 by 7. See, that is why the product will 7 7 cancel, 6 is cancel, d equals s into t. So that is the concept here. This is same as percentage increase and decrease. Right? Let's go to the next question. A car travels x kilometers at 60 kilometers per hour and then travels for another 2x kilometers at 40 kilometers per hour. Find its average speed over the entire distance. As you all know, what is the formula for average speed? Total distance by total time. So what is the total distance here? X plus 2x, which is 3x, divided by total time, t1 plus t2. What is t1? x by 60. What is T2? 2x by 40. So I should just add this. This is T1, this is T2. So x by 60 plus 2x by 40. 2x by 40 is nothing but 1 by 20. So 3x divided by x by 60 plus 2x by 40 will be our answer. So this will be 1 by 20. So this is equivalent to 3 divided by, I can cancel x, so this doesn't matter. So 3 divided by 1 by 60 plus 1 by 20. What is this? 20 plus 60 divided by 20 into 60. Or this I can say 3 by 60. This multiply 3 to the numerator and denominator. So we'll have 3 by 60. So 4 by 60 is 1 by 15. So this denominator is equal to 1 by 15. So 3 into 15 is nothing but 45 kilometers per hour. Okay, right? That's so we have distance x. So x, so this is one part. Next it is two parts. So here I am not bothered about the distance. I am just bothered about the ratio of the distances. Since that he's traveling one part at 60 kilometers per hour and two parts at 40 kilometers per hour. The total distance will be three parts. Let's say 3 divided by total time. X by 60 is 1 by 60 plus 2 by the two parts of the distance at 40, which is 2 by 40. If we simplify this expression, I'll have 45 kilometers per hour. Hence the average speed will be 45 kilometers per hour. Okay, so the simple formula which you have is total distance by total time. So here the distance are not the same. Had the question been, if the distance is given as x kilometers at 60 kilometers per hour and another x kilometers at 40 kilometers per hour, here you can directly apply the formula 60 and 40. The average will be 48. 2 into 60 into 40 by 60 plus 40, which will give me 14 kilometers per hour. For this problem, it is 45. Now let's see the next question. Similar concept. Can you just try this question? I'll just give you a minute. So here we have a person Runa covers a distance P to Q at uniform speed of 60 and the distance Q to R at uniform speed of 40. What is her average speed for the entire journey if the ratio of the distances PQ and QR is 3:2? So I have PQ, then I have QR. The ratio of the distances is given as 3 and 2. So 3x and 2x. Okay. So this at 60 kilometers per hour, this at 40 kilometers per hour. Now we know what is the formula for average speed, total distance by total time. So I will not take 3x and 2x, I can just say 3 and 2. So total distance is 5 divided by total time. 3 by 60 plus 2 by 40. What is 3 by 60? 1 by 20. What is 2 by 40? 1 by 20. So 3 by 1 by 20 plus 1 by 20 is nothing but 2 by 20, which is 1 by 10. So 5 by 1 by 10, which is equivalent to 50 kilometers per hour. Hence answer choice will be choice C, which is 50 kilometers per hour. Total distance by total time, 3:2 is the ratio, so we can just say 3 and 2. So 3 plus 2 divided by 3 upon 60 plus 2 upon 40, which will give me 50 kilometers per hour. Next question. Person covers a certain distance traveling at a speed of 9 kilometers per hour for 1/3 of the distance and 2 kilometers per hour for the remaining distance. So here it's 1/3 and the remaining. Okay, total distance is some part. So 1/3, what will be the remaining? 2/3. So 1/3 of the distance and 2/3 of the distance. I can just say the ratio of the distance is nothing but 1:2. So this is one part. This has to be two parts. What would be the total distance? Now we know average speed. So this one part is traveling at 9 kilometers per hour. The remaining two parts is traveling at 2 kilometers per hour. So total distance by total time. So total distance will be 3 divided by total time 1 by 9 plus 2 by 2, which is nothing but 3 divided by 1 by 9 plus 1, which is 10 by 9. So 3 by 10 by 9 is nothing but 27 by 10, which is equivalent to 2.7 kilometer per hour. Hence our choice will be C, which is 2.7 kilometers per hour. See, average speed, total distance by total time. So here the ratio of the distances is more than enough to solve the given question. Let's see the next question here. A man gets late by 20 minutes if he covers the distance between his house and office at speed of 50 kilometers per hour. Okay, so I'm late by 20 minutes if I travel at 50 kilometers per hour. If he increases the speed by 10 kilometers per hour, which means the speed is becoming 60 kilometers per hour, he reaches office 10 minutes early. Find the distance between his house and office and also the speed required to reach the office in time. So we have the formula distance equals speed into time. Right, now man gets 20 minutes, so the distance is the same. So 20 minutes late if he covers the distance at a speed of 50 km per hour. So when the actual speed is s, actual time is t, actual distance is d. So this d is equal to, when the speed is 50 kilometers per hour, he's 20 minutes late, so I have to convert it to hours. Therefore he is 1 by 3 hours late. So 20 minutes is nothing but 1/3 of an hour. Okay, so when he travels at 50 kilometers per hour, he's 1/3 hours late. So the time taken by him is nothing but t plus 1 by 3. So d will be equal to 50 into t plus 1 by 3. When speed is 50, the time is t plus 1 by 3. So time is increasing, therefore speed is actually reducing. So x should be greater than 50. Okay, next, if he increases his speed by 10 kilometers per hour, if he increases his speed by 10 kilometers per hour, so when the speed is becoming 60 kilometers per hour, he reaches his office 10 minutes early. So what is 10 minutes? 1/6 of an hour. This 10 minutes is 1/6 of an hour. So t minus 1 by 6 hours. So now we have the equations. So d equals st. If I just substitute d equals s and t, we will be able to get. So here instead of d, put s and t, or equating both equations, you will get the value of t. So 50 into t plus 1 by 3 will be equal to 60 into t minus 1 by 6. If we solve this equation, I will have 50 into t plus 1 by 3 equals 60 into t plus 1 by 6, or 50t plus 50 by 3 equals 60t minus 60 by 6. So what is 60 by 6? 10. So here if I replace, so I'll have 10t equals 50 by 3 plus 10, which is 80 by 3. Right. Therefore, what is t? T will be equal to 8 by 3 hours. So the actual time is 8 by 3 hours. So when t is 8 by 3, what is the distance? So when t is 8 by 3, so 8 by 3 plus 1 by 3 is 9 by 3. So if I just substitute 8 by 3 here, so d equals, substituting 8 by 3 here will be difficult. So here it is easy, because 8 by 3 plus 1 by 3 will become 9 by 3, which is 3. So this whole term will become 3. So 50 into t plus 1 by 3. Okay, now t is 8 by 3, so this whole term will become 3. So 3 into 50 will be 150. Hence the required distance is 150 kilometers. So I know the distance. 150 kilometers. I know t 8 by 3. So distance by t will be the speed. So 150 divided by time, which is 8 by 3. So 8 into 3. This will be the speed. So 450 by 8 will be the speed. What is 450 by 8? 5 8s are 40, 6 8s are 48. Balance is 2 by 8, which is 1 by 4. In the required speed will be 56 1 by 4. So distance is 150 kilometers and speed is 56 1 by 4. Hence choice A will be our answer. So we have the equation SG. S is 50, this is t plus 1 by 3, S is 60, t minus 1 by 3. So both are equal. When you simplify this, you will get t, substitute in the in any equation, you will get d, then divide, you will get S. Okay. Let's see how this question can also be solved. So instead of writing that equation SG, we know that a man gets late by 20 minutes if he travels the same distance at speed of 50. Okay. So what is the distance? Distance BD. Now, if I travel at 50 km per hour, so D by 50 is the time taken. He is late by 20 minutes. Okay. If I travel at 60 km per hour, I'm early by 10 minutes. So the time difference between me traveling at 50 kilometers per hour and 60 kilometers per hour is 30 minutes. I'm traveling at 50 kilometers per hour. I'm late by 20 minutes. If I have to reach at 10 o'clock, I'm late by 20 minutes. I'm reaching at 10:20. Right? If I'm traveling at 60 kilometers per hour, I'm early by 10 minutes. I'm reaching at 9:50. So the time difference between 9:50 and 10:20 is 30 minutes, which is nothing but the time difference between me traveling at 60 kilometers per hour and 50 kilometers per hour will be 30 minutes. So d by 50 minus d by 60 will be 30 minutes. What is 30 minutes? 1 by 2 hours. So if I just simplify this equation, I will have 60 minus 50, which is 10 divided by 3000 will be equal to 1 by 2. So 10d. So if I just cancel, I'll get d as 300 by 2. So d will be 150 kilometers. If I can get d, then I can find speed using the equation d equals s into t. So now I know the distance. Now a man gets 20 minutes late if I travel at 50 kilometers per hour. So if I travel at 50 kilometers per hour, so the distance 150. If I'm traveling at 50 kilometers per hour, what is the time taken? 3 hours. So this 3 hours, I'm 20 minutes late. So the actual time should be 20 minutes less than 3 hours, right? So what is 20 minutes less than 3 hours? 2 hours 40 minutes. So 2 hours 40 minutes is the correct time. What is 40 minutes? 2 by 3 hours should be the actual time which I should take to reach office, which is nothing but 8 by 3. Now I know the distance is 150 divided by 8 by 3 will be the speed. So which is equivalent to 450 by 8, which is 56 1 by 4. So without even writing the equation substituting, we just get the logic and do it. This is the other way of doing. Okay. The more simpler way, we have our options. Okay, let's see. A man gets late by 20 minutes if I travel at 50. Okay, so I'm getting late by 20 minutes if I travel at 50. So I should travel at higher speed more than 50? Yes. If I increase the speed by 10, will I reach? No. I'm early. So if I travel at 60 kilometers per hour, I'm reaching early. So if I travel at 50 kilometers per hour, I'm late. So minus. If I'm traveling at 60 kilometers per hour, I'm early. So plus. So I should travel at some speed between 50 and 60 for me to reach on time. So simple. What is the question? Distance and the speed required to reach the office on time. So my speed should be between 50 and 60. How many options are having the speed between 50 and 60? There's only one option. You can just tick this option, move on to the next question. See, the options are given like that. The distance are same, but the options with speed are different. I can definitely say my speed should be more than 50 and less than 60 for me to reach on time. So there's only one option between 50 and 60. Just take that option and move on to the next question. Okay, let's see the next question here. If a person travels in a car at a speed of 30 kilometers per hour, he would reach his destination in time. Okay, now what is it? travel at 30, I'll do the destination. So distance equals speed into time. So what is the speed here? 30 kilometers per hour in time. So into t. Right? So d is nothing but 30t. T is the actual time taken. Okay, so this distance is nothing but 30t. He covers half of the journey in 4/5 time. So the total distance is how much? 30t. So I have 30t distance. So half of the distance, let's say 15t. The remaining half will be the other 15t. He covers half of the distance in 4/5 time. So this 15t, what is the time taken by me? 15t is the distance here. Okay, this is not the time. This is the distance because distance equals 30t. 30 times the time taken. This 15t distance is traveled by me in 4/5 time. Right? What should be his speed for the remaining part of the journey so that he reaches his destination in time? So the total time should be t. Okay, so 4/5 time. What is the balance time? 1/5 time. So what is the speed for the remaining journey? So remaining distance by remaining time. So what is the remaining distance? Half. So which is 15t. So the remaining distance of 15t, I should take how much time? 1/5 of the time. If I just cancel, what will I get? 45. tt will cancel. So 15 into, sorry, 75. So the 75 is nothing but the speed for which I should travel the remaining distance in 75 kilometers per hour. What is the time taken? That is not required. That is not the question. Okay, whatever be the time, this value 75 won't change. So you can say time is 1, 2, 3, 4, 5. It doesn't matter. So assume 1 hour. So the distance will be 30 kilometers. So 15 kilometers I'm traveling at 4/5 time. Remaining 15 kilometers, how much time? It will be the same 75 kilometers per hour. To make it simple, if we have, see, 4/5 time, let's say the total time is 5 hours, I can assume. So when t is 5, so 30 into 5 will be 150. Now distance is 150. Now I have half. So 75 kilometers and the next 75 kilometers. This 75 kilometers, 4/5 time I am traveling. What is 4/5 of 5 hours? 4 hours. So the remaining 75 kilometers I should travel in 1 hour. So what is the average speed? 75 kilometers per hour. See, you can even try substituting numbers and solve the question. Even without substituting, just have 30t. Whatever be the value of t, it will cancel. So what is the average speed for the first half of the journey? 15 divided by 4 by 5, which is 75 divided by 4, which is 20 minus 1.25, which will be 18.75. Okay, this is the average speed for the first half of the journey, but that is not required. So for this question, the answer is 75 kilometers per hour. Next question. A man covers the distance between his house and factory daily at a certain speed. If he travels at 3 kilometers per hour faster than his usual speed, he covers the distance 1 hour earlier. Okay, so let's say the distance is the product of speed and time. Now, if I travel at 3 kilometers faster, so the same distance, if I travel at 3 kilometers faster, so this will become s plus 3. So everything in kilometers, no problem. Faster than the usual speed, he covers 1 hour earlier. So the time taken by me will be t minus 1. This is the first equation. Next, instead, if he travels at 3 less than his usual speed, okay, so the same distance, instead, if I travel at s minus 3, okay, he takes 2 hours more to cover the distance. The time taken by me will be t plus 2. Right? What is the distance between his house and the factory? So I know d equals st. So this equation I can just expand this. So what is s plus 3 into t minus 1? st plus 3t minus s minus 3. Similarly, this s minus 3 into t plus 2 will be st minus 3t plus 2s minus 6. This is equal to d. What is d? st. So I can say this equation is equal to st. This equation is also equal to st. So ST and ST will cancel out each other. So I'll have 3t minus s minus 3 equal to 0, and minus 3t plus 2s minus 6 is also equal to 0. So I can just rewrite this as 3t minus s equals 3 and minus 3t plus 2s will be equal to 6. I have two equations and two unknowns. If I add both the equations, this will cancel. 2s minus s will be s, 6 plus 3. So I'm just adding the equation. So minus s plus 2s will be s, 3 plus 6 will be 9. Hence s is 9. If I just substitute in any equation, if s is 9, minus 9 goes, that's it, plus 9. So 9 plus 3 is 12. 12 by 3 will be 4. Hence t will be 4. Yes, right. So we have 9 plus, so 3t minus s equals 3. So 12 by 3, 3t. So 12 by 3 will be 4. Hence t is 4. Hence the required answer is, what is the question here? Find the distance between his house and factory. So s into t is the answer. So 9 into 4, which will be 36 kilometers. If you want, you can check. So d equals s into t. What is s? 9 into 4. Now, when s is increasing by 3, this will become 12. This should decrease by 1, 2, tallied. When s is decreasing by 3, this will become 6. This will increase by 2, 6. Tallied. See, every case the product is the same. If you want, you can just check. But what you're supposed to do is d equal to st. You have the equation, just substitute, solve the simple equation, you get the answer of s and t. Hence the answer 36. Let's see the next question. Two men A and B start from a point on a scooter at a speed of 30 kilometers per hour and 50 kilometers per hour respectively. How many kilometers apart will they be after 5 hours? If they move in the same direction, B if they move in the opposite direction. So first option is A and second option is B. Now speeds are 30 and 50. Okay. Now after 5 hours, okay, so two people, if they travel in the opposite direction, right, they're starting from the same point. See, they are not traveling from the, they are not traveling from two different points. So from the same point, so if this is the point they are starting, so one person is going in this direction, other person is going in this direction. He is going at 30, he is going at 50. For every hour, the distance between them will increase by 80. So they are traveling in opposite direction. Okay, so when they're traveling opposite direction, right, so the effective speed is sum. So when they're traveling either this way or towards each other, so when they're traveling from two different points, it's added. Again, two opposite points also, it is added. From same point to opposite direction, I should just add the speed. So after every hour, the distance will be 80. So what is the question? How many kilometers apart will they be after 5 hours? So after every hour, it is 80. So 5 hours, it has to be 400. Now, when they travel in the same direction, so at this point, he travels at 50, the second person travels at 30. So for every hour, when he has traveled 50, he would have traveled 30. So the difference is 20. So for 1 hour, it is 20. For 5 hours, 1 hour, it is 20 difference. For 5 hours, it has to be 100. So same direction, it is 100. Opposite direction, it is 400. So the required answer will be 100 comma 400, which is choice B. Got it? So two people from same point, opposite direction, it will be 80 every hour. So 5 hours 400. Same direction, it will be, difference will be 20 every hour. So 5 hours it will be 100. So same direction it is 100, opposite direction is 400. So choice B will be our answer. Be careful, it's not 400 comma 100, it's 100 comma 400. Okay, next we'll move on to a concept which is trains. Okay. Let's say two trains are traveling on parallel tracks. Okay, now let's say this is a train, right, which is traveling at, say, the length of the train is 100 meters. Make it simple. Okay, just visualize, length of the train is 100 meters and the speed of the train is 10 meters per second. So length of the train 100 meters, speed of the train 10 meters per second. Now what is the time taken by this train to cross a man standing on a platform? or a vertical pole. Okay, so that or a point. Okay, now man standing on a platform, time taken by this train to cross this man completely. Now the length of the train is how much? 100 meters. Speed of the train 10 meters per second. The train is coming mid from here. For every 1 second the train travels 10 meters. The man is not moving, the man is stationary, or the vertical pole. Okay, now this is stationary, this point. So train every second it travels 10 meters. So after 10 seconds the train's last end point will be at this particular position. So after 10 seconds the train will cross completely. So distance by speed, distance here is the length of the train. So length of the train is 100 meters, speed of the train 10 meters per second. So man standing on a platform, he will take 100 divided by 10, which is 10 seconds. Now if I take the platform instead of man, let's say a platform, the platform length is say 200 meter. Okay, let's take the platform as this. So the platform length is 200 meter. This white color is the platform. So the length of the platform is 200 meters, length of the train 100 meters. Now what is the time taken by the train to cross this platform? 100 meter, 10 meters per second. Now if this is 100 meter, the train is coming, it met, platform is stationary, it won't move. So here after the train has touched, come to the entrance, for every second the train will travel 10 meters. So 10 meters for this engine to go to the end of the platform. The length of the platform is 200, so the engine should travel 200. So for the engine to go here it will take 20 seconds, because every second is 10 meters, 200 meters, 20 seconds. But has the train completely crossed? No. So this train should go out. So this train should actually travel its own distance extra. So it should go. The total distance traveled by the train will be the length of the train plus length of the platform. So 100 plus 200 is 300 divided by speed of the train will be the time taken. So 300 divided by 10, which is 30 seconds. So the time taken by the train to cross the platform will be 30 seconds. This is the second model. Now let's take two trains running on two parallel tracks. Okay, train 1, train 2. This is train 1, this is train 2. So train 1 of length 100 meters, 100 meters per second. Train 2 of length 200 meters, 200 meters, 20 meters per second. 100 meters, 10 meters per second. 200 meters, 20 meters per second. So assume this is a platform which is moving platform, something like that, hypothetically. Okay, so 100 meters, 10 meters per second. 200 meters, 20 meters per second. What is the time taken by both the trains to cross each other when they are traveling in the same direction, when they are traveling the opposite direction? Okay, let's say two parallel tracks, two trains, when they're traveling opposite direction, they're coming together. Okay, now they met. After meeting, this train will travel 10 meters every second, this train will travel 20 meters every second. So both are moving, so together they will travel 30 meters every second. So when this has traveled 10, this would have helped him. When this has traveled 20, this would have traveled 10. So the distance between the engine of both the trains will be the difference between the engine, the distance between the engine of both the trains will increase by 30. Now it is 0. After 1 second it will be 30. After 2 seconds it will be 60, and so on. Now what should be the difference for the train to cross completely? It should be like this. So the difference between the engines should be the sum of the lengths of the two trains, which is 200 plus 300. So 300 divided by opposite direction, it's 20 plus 10, which is 30. In 10 seconds both these trains will cross completely. Understood? Because the difference between the engines is counted. So when this is at the end point, the travel cross completely, the difference between the distance between the engines from this end point to this end point will be the sum of the lengths of the two trains. Now when they travel in the same direction, okay, so this is 10 meters per second, 100 meter, 200 meter, 20 meters per second. So this train is faster, this train should overtake. So from here initially it will meet, so the distance is like this. Now for this train to travel completely, it should cross this train and it should go out, so which is the same as the total distance is 100 plus 200. It should travel 100, then its own length 200. So total distance will be 300 divided by difference of the speed, same direction. So here this is traveling at 10. So for every minute, so for every second, this will just increase by 10, 10, 10, 10, 10. Okay, so here I am just taking the difference between the engine of this first train and the last carriage endpoint of the second train. So now it is 0. So after every second, this has gone 20, this has gone 30. So the difference will be 10. So 10, 10, 10, 10, 10. So it will cover this, it will come to the engine, front part of this train. it will cross completely. So 300 divided by difference of the speeds. If both the trains are traveling the same speed, it will never overtake. So that is the concept with trains. Got it? Now let's summarize this. Length of the train is 100. So I just explained it orally so that you can visualize it. Okay, so don't memorize or mug up the formula, just understand how it is done, why you are adding the lengths and why you are separating the speeds, why you are adding the speeds. Lengths are always added. Length of the train 100 meters, speed of the train 10 meters per second, time taken to cross a vertical pole 100 divided by 10. Next, time taken to cross a platform of length 200 meter, 100 plus 200 by 10, which is 300 by 10, which is 30 seconds. Now two trains, train 1 of length 100 meter, train 2 of length 200 meters. Speed of the first train 10 meters per second, speed of the second train 20 meters per second, same direction. 100 plus 200 divided by 20 minus 10, because it should overtake the other train. So it's 10 meters per second faster than the other train. So which will give me 300 divided by 10, which is 30 seconds. Opposite direction, 100 plus 200 divided by 20 plus 10, which will be 30, which is 300 by 30, which will give you 10 seconds. Now both of the trains will travel completely in 30 seconds if they travel in same direction. Opposite direction 10 seconds. I'll just give some 30 seconds for you to read the slide and understand this. Okay. So that by the time the train crosses. Okay, just a joke. Okay. Just go through this. So I hope the train has crossed now. So now let's move on to the next part. Some questions based on this model. Okay. A train travels for 8 hours. The first half of the total distance for 30 kilometers per hour, second half at 50 kilometers per hour. Find the total distance traveled. Okay, here there is nothing related to the length of the train. So the train travels for 8 hours. First half of the total distance. Okay, be careful. So when I say first, so total time is 8 hours, and first half of the total distance at 30 kilometers per hour, second half of the distance at 50 kilometers per hour. So sometimes they will say first half of the time. You should be careful in that case. Okay, so here our total distance is d. So first half is d by 2 and the second half is another d by 2. So instead of having d as the total distance, let's say 2d is the total distance, or 2x. So first half is x, second half is another x. So x distance, another x distance. Okay, so let me say the first part is x and the second part is another x. Okay, so total time is 8 hours. First half of the distance is 30 kilometers per hour. So this distance I am traveling at 30 kilometers per hour, and the second half at 50 kilometers per hour. So this distance I am traveling at 50 kilometers per hour. Find the total distance traveled. I have to find the total distance. Total time is how much? 8 hours. Now what is the time? Distance by speed. So for the first half I will take some time t1, second half I will take some other time t2. So this total is given as 8 hours. So we know first t1 is what? Distance by s1. So x by 30 plus x by 50 is equal to 8. So we have 30 plus 50, which will be 80 divided by 1500 equals 8. So if we just cancel dd, so I'll have 80x. So 8 will cancel. So which gives me x as 150. Now what is x? It's the first half of the distance. Therefore, what will be the total distance? It has to be 300 kilometers. Hence choice B will be our answer. You see, simple. I repeat, we have the total distance. So first half at 30, second half at 50. The total time will be x by 30 plus x by 50. This is given as 8. So the question is about 2x. So from the option, if you want to try, the options are 2x. So divided by 2 will give the answer. So divided by 2 400, x will be 200. If it's 300, x will be 150. If it is 320, x will be 160. If it is 360, x will be 180. Now, since you have an integer here, it should either have, since the denominator is 3, I cannot have a non-integer. So, x should be a multiple of 3. Be careful. So, 2x is given. So, x should be a multiple of 3. So, x cannot be 200. X cannot be 160. So, these two are eliminated. It has to be either 300 or 360. If I say 300 and half of that, it should be a multiple of 30 as well as a multiple of 50, because here it's an integer. This should also be an integer. The multiple of 30 and 50 should be a multiple of 150. There is only one option. You can just take this option, move on. Or this solving this equation is also not a tedious process. You'll have 300 as the 2x. Here the options are okay, but sometimes if they give 150, you should be careful. Here if you do with x, d by 2 and d by 2, you'll get the same answer. You will get d. Okay, so here it is, x is 150, therefore 2x is the total distance, hence 300 kilometers will be the answer. Let's see the next question. So I hope you can do this question yourself. Take your time and do this question. You have the concept with you. No formula, no writing the formula, no understanding and substituting, just no thinking, or just visualize what is happening, just get the logic behind it and try to get the answer. A train traveling at a speed of 60 kilometers per hour passes a pole in 9 seconds. What time will the train take to cross a platform 250 meters long? Okay, so platform 250 meters long. Train traveling at a speed of 60 kilometers per hour. Now, for me to find the time taken by the train to cross a platform, I should know the length of the train. For this, I use the first clue. So, speed is 60 kilometers per hour. Pass a pole in 9 seconds. So I'll convert the 60 km per hour to into meter per second. So 60 kilometers per hour into meters per second will be lower unit. So I'll multiply by 5 by 18. This is the speed of the train. What is the length of the train? Speed into time. So it takes 9 seconds. That will be the length of the train. If we just cancel, this will be 2. Just remove, it will be 30. So 30 into 5 will be 150. Hence the length of the train is 150 meters. Length of the platform 250 meters. So total length 400 meters. What is the question? Time taken divided by speed of the train. Since this is in meter, you have to take meters per second. So what is the meter per second of 60 kilometers per hour? 60 into 5 by 18. Just write 60 into 5 divided by 18. Take it to the numerator. Okay. Now 0 0 vanish. So 6 will become 3 if I cancel, 5 if I cancel, this will become 8. So 8 into 3 will be 24 seconds. Hence answer choice will be choice B. Simple. So I repeat. So we have train speed 60 kilometers per hour, cross a pole. So from this I can find the length of the train, which is 60 into 5 by 18 into 9, which will give me 150. Platform length is 200, since the total distance is 400 divided by speed of the train, which is nothing but 60 into 5 by 18. If we simplify this, I'll have 24 seconds. The answer is 24 seconds. Okay, similar question, similar model, you can do it orally. A train 600 meters long cross a bridge 2400 meters long in 3 minutes. Find the speed. So 600, 2400 is 3000 meters. So 3000 meters, it takes 3 minutes divided by 3 minutes. So 3 minutes, this is in meters, so I'll convert it to seconds. So 3 minutes will become 3 into 60 seconds. So now I have meters per second. So what is the question? In kilometer per hour. So I should multiply with 18 by 5. This will be our answer. So 3 will be 1000. So here 60, cancel it. This will be 100 now. So 100 by 5 will be 20. So this will become 3. So 20 into 3 will be 60. Hence the speed of the train will be 60 kilometers per hour. Or I can directly convert this into kilometers and this into hours. So 600 plus 2400 is 300, which is 3 kilometers. 3 kilometers in how much time? 3 minutes. 3 minutes is nothing but 3 by 60 hours. So the final time answer will be 60 kilometers per hour. So simple. Choice D will be our answer. Next question. Again, similar model. Let's try it all together. 100 meters in length, cross a telegraphic post, cross a pole in 10 seconds. Therefore, what is the speed of the train? 10 meters per second. While reading itself, I'll get the numbers. Okay. Another train of the same length. Okay, this is also 100 meters length. Cross a platform 125 meters in 15 seconds. So this train takes 15 seconds to cross a platform of 125 length. Okay, so for 125 plus 100, so it takes actually 225 is the distance travel. This takes 15 seconds. And so what is the speed of the train? 15 meters per second. So speed of the second train will be 15 meters per second, because the length of the train is 100, length of the platform is 125. So 225 divided by 15. Okay. What is the difference of the distances covered by the two trains in 3 hours? Okay. So both the trains are traveling. So difference of the distances. Okay. For every hour, how much this travels? For every hour, how much this travels? Now, for every second, this travels 10. For every second, this travels 15. So what is the difference for every second? 10, 15, it's 5 meters per second. So for every second, the difference between the distance traveled by the two trains will be 5 meters. I have to take for 3 hours. So for 1 second, it is 5 meters. For 3 hours, 5 into 60 into 3. That's all. So for 1 hour, it will be 12. For 3 hours, see 5 into 60. See, for 1 second, it is 5 meters. For 60 seconds, it is 1 minute. So 60 seconds, this is 1 minute. So I want to have for hours. So into another 60. So I have 5 into 60 into 60 into 3. 5 into 60, 300. 300 into 180. So 300 into 30 into 60 is 180. 3 times 80 will be 54,000 meters, which is nothing but 54 kilometers. Clear? Right? So I have one, I am just converting this. Okay, this is one, or directly if you get 5 meters per second is the effective, right? So 5 meters per second, I have to convert to kilometers per hour, because that is the question in 3 hours, right? So answers on kilometers in 3 hours. So 5 meters per second, if I convert to kilometer per hour, I'll multiply by 18 by 5. So this is nothing but 18 kilometers per hour. So 18 kilometers per hour for 3 hours, this is equivalent to 54 kilometers, hence our answer. So here it will be choice A. Let's move on to the next question. A train leaves Hyderabad at 5 a.m. and reaches Bangalore at 3 p.m. Another train leaves Bangalore at 7 a.m. and reaches Hyderabad at 5 p.m. When do the two trains meet? Okay. So train leaves Hyderabad at 5 a.m. and reaches Bangalore at 3 p.m. So what is the time taken? 5 a.m. to 5 p.m. is 12 hours. So this will be 10 hours. Okay, so train 1 takes 10 hours. Another train leaves Bangalore at 7 a.m. It starts at 7 a.m. reaches Hyderabad at 5 p.m. So what is the time taken by this train? 7 a.m. to 7 a.m. minus 2. This is also taking 10 hours. So can I say both the trains are traveling at the same speed? Since they are traveling the same speed, you can take any speed. Let's say 1 kilometer per hour. Let's say the distance between Hyderabad and Bangalore is say 10 and the speed is 1 kilometer per hour. Therefore, they will take 10 hours. It's an assumption. Okay. So now I have the distance is 10. Let's separate into 10 parts. So this is 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now this is at 5 a.m. So for every hour, the train will be, so 6 a.m. the train will be here at 6. At 7 a.m. the first train will be here. Now at this time, the other train starts. This starts at 7 a.m. At 8 a.m. this will be here. This train will be here at 8 a.m. At 9 a.m. this will be here. This will be here. At 10 a.m. this train will be here, this train will be here, because for every hour it's at 11 a.m. both of the trains will be at this point. So at 11 a.m. they meet. Hence the answer will be choice B. Right? So here this is just based on logic, we are just solving this question. But after you get this 10, the effective is 1. So 5 a.m. So since the speed is same, so 2 hours, I'm assuming 10, the two distances are traveled, so 2 meters or 2 kilometers are done. So the remaining 8 is the remaining distance. So for every 1 traveled by this train, this also travels 1. So 8 divided by 1 plus 1, which will be 8 by 2. So which takes 4 hours from 7 a.m. for both the trains to meet. So 7 plus 4 will be 11 a.m. So both of the trains will meet at 11 a.m. Next, a train leaves Hyderabad at 6 a.m. traveling at 60 kilometers per hour. Another super express train leaves Hyderabad 1 hour late, traveling at 75 kilometers per hour. When and at what distance from Hyderabad will they be together? Okay, so at 6 a.m. So first train at this point at 6 a.m. Okay, at 60 kilometers per hour. Fine. Next, so at 7 a.m. where will this train be? At this point, say 7 a.m. So can I say this distance is nothing but 60 kilometers? Right. So I have a train which is starting at this point at 6 a.m. at 60 kilometers per hour. So this train at 7 a.m. will be at this point, right? So the distance between these 2 points is 60 kilometers. Now the other train starting point is this. Now the second train starts from this point at 75 kilometers per hour, right? So for every hour the difference between the distances should come down. So what distance, when and at what distance from Hyderabad will they be together? So for this train to catch this train, it should be faster. So 75 minus 60 is the relative speed, which is 15 kilometers per hour. So for every hour the difference will come down to be 15 15. I should cover a total of 60. So 60 divided by 75 minus 60, which will be 60 by 15, which will take 4 hours for both the trains to meet. 4 hours from 7 a.m. because 7 a.m. this train is starting. So 7 plus 4 will be 11 a.m. At 11 a.m. both the trains will meet. So for 4 hours this train has traveled. This train has traveled for 5 hours because from 7 to 11 it's from 6 to 11. So 5 hours the distance is 300. 4 hours this distance will also be 300. Hence the total distance is 300, and at what time? 11 a.m. So D will be our answer. Simple. So starting at 6, 1 hour 60. So 60 divided by difference of the speeds 15. So 4 hours. So from 7 it's taking 4 hours. So for 4 hours this train has traveled 300. That train would have traveled the same 305 hours because 4 plus 1 it started at 6 a.m. Hence the distance will be 300 kilometers, and at what time? At 11 a.m. the trains will meet. The next question. Train A traveling at a speed of 30 kilometers per hour overtakes train B in 72 seconds. Now, train A 30 kilometers per hour. Do you know the length of the train? I don't know. It's overtakes another train B. Do you know the length of the train B? No. So let's say A and B. So length of the train A is A, length of the train B is B. Now train A, so always distance is added. So distance divided by speed overtakes. Therefore, this is faster. So this train speed is 30. That's given. Speed of the second train, let me take it as S. So minus S. So everything in kilometers per hour. So I'll multiply by 5 by 18 to have meters per second, which will give me 72 seconds. See, just by reading the first line, I'm getting this data. I haven't read the next part. If train B travels in opposite direction, so here same direction, so overtakes. If train B travels in opposite direction, it takes 24 seconds for train A to cross B. So same distance I'll add. So I'll have A plus B divided by opposite direction should be 30 is the speed of the first train. Let the speed of the second train be S, so 30 plus S. So this is in kilometers per hour. So I should convert to meters per second, 5 by 18. This should be equal to 24 seconds. Now find the length and speed of the train B, which is B, given that both the trains are of equal length. Now my job is simple. Both the trains are of the same length. So instead of this A plus B, I can just say 2A or 2B. Okay, now this will be 2A. This will also be 2A or 2B, anything, since both are equal. So 2A by 30 minus S. This, therefore, if I just divide both the equations, everything will cancel. I can find the speed. Then if I substitute, I'll find A. Now, if I just divide both the equations, I'll have 2A as 72 times the product, so 5 by 18. So if I just equate, either divide or equate. So in this case, when I divide both, 5 by 18, 5 by 18 will cancel. 1 by 2A will cancel. 1 by 30 minus S divided by 1 by 30 plus S, which will give me 30 plus S divided by 30 minus S equals 74 divided by 24, which is 3. Now 30 plus S equals 90 minus 3S. So 3S comes this side, 4S. 30 goes that side, 60 minus 60. Therefore S equals 15. Now I know S is 15. What is the question? Find the speed of the train. B. Find the length and speed. I know S is 15. I have to find the length. We have the first equation, which is 2A divided by 30 minus S into, or 2A should be equal to 72 into 30 minus S into 5 by 18. So 30 minus S is what? 30 minus 15, which is 15 into 5 by 18. Hence I can find A. So just 18, this will go 4. So if I just cancel 2, this will become 2. 15 into 5, 75. 75 into 2, 150. Hence A is 150, which is same as B. So length of the train will be 150 meters and the speed of the train is 15 kilometers per hour. These two equations, solve the equations, find S, just substitute. Okay. Now let's move on to the next concept, which is boats and streams. Similar to the relative speed here. So now when I say here, I mean boats and streams. The speed of the boat, speed of the water current, I say. Speed of the boat in still water or speed of the man who is traveling on a boat. I can use different terms. So just assume the two terms, boat, water. Speed of the boat is B. Speed of the water current or speed of the stream or speed of the wind or speed of the tide, whatever they give, it is W. So boat is B, water is W. Man, M or B. You can just say speed of the man rowing is again the speed of the boat. Okay, so speed of the boat is B, speed of the water is W. So now we have something called as upstream speed and downstream speed. Okay, when I go in a boat in a river, the water is stationary, it's speed of the boat in still water. If the water is flowing in a river, the water flows. So there either it'll go upstream, so it'll go against the water, or it'll come downstream, I'll come with the water. Now let us take speed of the boat in still water. When the water is still, speed of the boat is 5 kilometers per hour. Okay, speed of the water current is 3 kilometers per hour. So boat is 5, water is 3. Now if I'm going up the stream, so I'm going against the water. If I go 5 up, the water will push me down. So effective is only 2 kilometers because plus 5 minus 3 because it's opposing. So effectively I'll travel only 2 kilometers per hour. So here it's boat minus water. It's upstream. If I'm coming downstream, I come 5. The water will help me with 3. So 5 plus 3 will be 8. So upstream is 5 minus 3. Downstream is 5 plus 3, which is 8 and 2 kilometers. So upstream is 5 minus 3, which is 2. Downstream is 5 plus 3, which is 8. So 2 comma 8 are the up speed and down speed respectively. Now I gave you the boat speed and water speed to find up and down. If I give up and down, say 8 and 2 respectively, can I find boat and water? Yes, I know up, which is 8, which is B minus, up is 2, which is B minus W. Down is B plus W. I have two equations. If I add two equations, I'll get 2B, which is 10. And B will be 5 and W will be 3. That is the concept here. Now let's see. The speed of the boat is B. Speed of the water current is W. What is down speed? Boat plus W, which is expressed as D. In book you will have U's and V's or P's and Q's. Just forget about it because it's confusing. So just have down speed is D, up speed is U, boat speed is B, water speed is W. So down speed is B plus W. Down it's helping. Okay. See, they can frame the question like this. A man is coming from, he jumped from a parachute, okay, so, or he jumped from the airplane using a parachute, he comes down, so the wind will help him. Or from a bridge he's sliding down, the wind will help him, the effect, something like that, okay. So it need not be only boat and water. So here it's boat, water. So B plus W is down speed, any down speed which will help. So up speed is against, which is B minus W. Equation 1, equation 2, if I add both the equations I'll have 2B. If I subtract both the equations I'll have 2W. Equation 1 minus equation 2, down minus W. So therefore both speed will be down plus W add divided by 2. If I subtract down minus W divided by 2 will be water speed. That's all. Okay, so just remember this, boat, water, up is B plus W, down is B minus W. If I add, I'll get add and divide by 2, I'll get boat speed. Subtract and divide by 2, I'll get water speed. Always remember down minus up, because down speed is more than the up speed. When I say down, it's the relative effective speed. Okay. Now let's go to the next question based on this. Man can swim downstream. So what is this meaning downstream? Which is down speed, which is D. And upstream at 6. So this is U. Find the speed of the man in still water. I had to find both speed and W. So we know that A down plus up divided by 2 or down minus up divided by 2. 18 by 2 is 9. 3 down minus up 6 by 2 is 3. So 9 comma 3 are the respective both speeds and water speeds respectively. Hence choice 3 will be our answer. Now let's move on to the next question here. A man can row a distance of 5 kilometers in 30 minutes with the help of a tide. See, with the help of a tide. So the distance is 5 kilometers. I can row 30 minutes with the help of the tide. So what is the help? I'm coming downstream. So speed of the man is, let the speed of the man be m, or b you can have. So let's say m, or let's have the same b. So b is the man's speed. B, tide is water. So plus w with the help. So 5 kilometer in 30 minutes. So this is the speed. So distance by speed is the time. So 5 kilometer, if we go at this speed, what is the time taken? 30 minutes. So convert to hours. Always remember, you should convert everything to hours. So 1 by 2 hours. Now, the direction of the tide reverses with the same speed. Now, if the direction of tide reverses with the same speed, so the effective will be B minus W. Now, he travels a further 10 kilometer in 5 hours. So, I travel 10 kilometers, the tide reverses. So, man speed, which is B, boat speed, minus, so I'm just replacing it as boat and water. So, minus tide speed is W. So this I am taking 5 hours. How much time would he have saved if the direction of the tide had not changed? So how much time would he have saved if the direction of the tide has not changed? Now in this equation, if we just cross multiply, I'll have B plus W equals 10. So here I'll have B minus W equals 2, 10 by 5. Add both equations and divide by 2. I'll have B as 6. Subtract both equations and divide by 2. I'll have W as 4. B plus W 6 plus 4 is 10. B minus W 6 minus 4 is 2. I know B and W. What is the question? How much time would he have saved if the direction of the tide had not changed? So I travel first 5, half an hour. That's not going to affect. The remaining 10, I travel at B plus W. Okay, because the direction has not changed. It's actually helping me. So what is B plus W? 10. So this will be 10. So 10 by 10 is 1 hour. So instead of 5 hours, now I'll take only 1 hour. So what is the time which I'm saving? 4 hours. Got it? Okay, this is, I'm finding the boat speed and water speed. Okay, just if you read the question carefully, a man can row a distance of 5 kilometer in 30 minutes with the help of the tide. So 5 with the help of the tide. So B plus W is given as 30 minutes, 1 by 2 hours. The direction of the tide reverses. So now he travels a further 10 kilometer in 5 hours. So 10 kilometer at B minus W, he is taking 5 hours. How much time would he have saved if the direction of the tide had not changed? So if it has not changed, I should just find 10 divided by b plus w instead of 10 divided by b minus w. I know 5 by b plus w is 1 by 2. Just double this equation, multiply by 2, right? What will I get? 10 by b plus w, which will be 1. It has to be 1. But 10 by b minus actual time is 5. The new time is 1 hour. Directly without even finding b and w, I can say it's taking 1 hour. Therefore, I'm saving total of 4 hours. Okay. Now, the time taken by a man to row downstream is 3/5 of the time taken when he rows upstream. Okay, what is the equation? Time taken row downstream, which is downtime. So what is that? Distance divided by down speed. What is down speed? Boat plus water. This is the downtime. Distance by speed. Always remember distance by speed. What is the distance? D. Speed is either adding or separating or the same speed. Okay. So time taken by man to row downstream. This is down speed. Sorry, this is downtime is equal to 3/5 of the time taken when he rows upstream. What is upstream? Up distance divided by uptime. What is uptime? B minus W. Okay, if the product of the speeds of the man and current both taken in kilometer per hour is 36, if the product of the speeds of both man and current, which is B into W, is given as 36, find the speeds of man and water current respectively. So here I can just cancel, dd will go off. So 5 into B minus W equals 3 into B plus W, just cross multiply. So I'll have 5B minus 5W equals 3B plus 3W. So 5B minus 3B will be 2B. 3W plus 5W will be 8W. Therefore B equals 4W. If I just substitute here, I'll get 4W square as 36. Therefore W square equals 36 by 4, which is 9. Hence W equals plus or minus 3, but since it cannot be negative, it is 3. Okay, so when W is 3, what is B? It is 12. Now what is the question? Find the speeds of the man and water current respectively. 12 and 3 is our answer. So choice A will be our answer. That's it. Okay. One more thing. One more way of doing the same problem will be, the question is about find the speeds of the man and water. We know the product is 36. How many options? 12, 3, 9, 4. Choice B can be eliminated. Choice D can be eliminated. Okay. Let's try with 12, 3. So if the speed of the man and water current is 12 and 3, we know D by B plus W is 3/5 of D by B minus W. So cancel D. So B plus W is what? 1 by 15. Is it 3/5 of 1 by B minus W, which is 9? 3, 3, 3. Yes. Hence it's tallied. Hence choice 1 will be our answer. You need not even check for choice D. If this is not tallying, just tick choice C and move on to the next question. Hence choice C will be also ruled out. Okay. So this is one of the way of doing question with options. Just be smart. Just think, it takes some practice, but you should know the traditional way of doing, how to frame the equation, how to write. Again, as we see, every question is just a 2 or 3 step method. You have to just simplify that given expression. For that, you should understand the given question. What is that they are saying? Okay. Ravi is 1 by 3 times as fast as Pradeep. If Pradeep has a head start of 50 meters, what should be the length of the race course such that both of them reach the finishing point at the same time? Okay, so I have Ravi, I have Pradeep. Ravi is 1 by 3 times. 1 by 3 is nothing but 4 by 3 times as fast. So what is the meaning of 4 by 3 times as fast as Pradeep? So when Pradeep's speed is 1 meters per second, Ravi's speed will be 4 by 3 meters per second. Or when Pradeep's speed is 3 meters per second, Ravi's speed will be 4 meters per second. Got it? So when his speed is 3 meters per second, his speed should be 4 meters per second, because I have the ratio is 4:3. Okay, when this is 4 parts, this has to be 3 parts, either 4 km per hour, 3 km per hour, it doesn't matter. So when Ravi is 1 by 3 times as fast as Pradeep, which means he is 1 by 3 times more, so which is 1 by 3 times more. 1 by 3 times as fast is 1 by 3 times more, hence the ratio will be 4:3. If Pradeep has a head start of 50 meters, what is the meaning? In a race, So Pradeep will start from here. Ravi should start from this point. So he has a head start of 50 meters. What should be the length of the race so that both of them reach the finishing point at the same time? So his speed is 3x, his speed is 4x. When he travels 3x, he should have traveled 4x. Therefore, this distance will be x. So x is given as 50, hence 4x is nothing but 200. Hence the required answer will be 200 meters. Simple. See, the ratio of the distance is 4 is to 3. The difference between them is one part. That one part is given as 50. So total race is 4 parts, which is 4 into 50, which is 200, because Pradeep is having a headshot of 50 meters. Okay, so he's already traveled 50, or he's starting from that point. So the total length of the race will be 200. It is not 150, because when he is traveling 150, he should travel 200. Therefore, the end points total race is from this starting point where Ravi started. Okay. Now, in a kilometer race, A beats B by 100 meters and C by 190 meters. So I have A, I have B, I have C. In a kilometer race, therefore 1000-meter race. A beats B by 100. What is the meaning? When A has traveled 1000, B has traveled 900. A beats B by 100 meters and C by 190. So when A has traveled 1000, C would have traveled 810. Okay, so this gives the distances traveled by them. So can I say the ratio of the speeds should also be this 1908, because at a fixed time when he's traveled 1000, he has traveled 900 and he has traveled 810. So therefore the ratio of the distance is 100, 900 and 810, which is same as the ratio of the speeds, because the time is fixed. For the same time when he has traveled 1000, he travels 900, he travels 810. Now what is the question? In a 500-meter race, by how many meters would B beat C? In a 500-meter race, therefore when B has traveled 500, what would be the distance traveled by C? This is in the ratio 10 is to 9. So A and B in the ratio 10 is to 9. B and C is also in the ratio 10 is to 9. So when he has traveled 500, he should have traveled 450. So in a 500-meter race, B would have beaten C by 50 meters. Understood? I repeat. So when I have B and C, it's 900 and 810. So which means for every 900 traveled by him, he would have traveled 810. Right? But for me to travel 500, so this is just 10% less. So at any time his speed is 10% less than his speed. So if he travels 100, he would have traveled 90. Same ratio. So when he traveled 500, he would have traveled 450. So in a race of 500 meters, he would have beaten by 50 meters. If the question is 1000 meters, he would have beaten by 100 meters. When he has traveled 1000, he would have traveled 900. Okay. Let's go to the next question. Two persons A and B move towards each other from P and Q respectively. So P and Q have A and B. They move towards each other. Okay. They meet 50 kilometers away from Q. Okay. So they meet at a point which is 50 kilometers away from Q. If the ratio of the speeds of A and B is 4 is to 1, if he travels 4 parts, he travels 1 part. So this distance is 4 part. This distance should be 1 part. That is the meaning. Find the distance between PQ. When he has traveled 50, he should have traveled 4 times 50, which is 200. So hence the total distance between P and Q would be 250 kilometers. Understood? Because the ratio is 4 is to 1 towards each other. They meet at 50 from Q. So one part is 54, part will be 200. So hence the total distance will be 200 plus 50, which is 250. Choice D will be our answer. Now, P and Q, 1200 meters apart, travel towards each other at the speeds of 20 and 30 respectively. So P and Q, 1200 meters apart, traveled speeds of 20 and 30 respectively. After how much time will they meet? So simple. So towards each other. So 1200 divided by 20 plus 30 will be 50. 120 by 5, which is nothing but 24 seconds. Hence the answer is 24. So simple. 1200 divided by sum of the speeds, 24 seconds. Meters and meters per second. Next, similar with circular path. A and B are running around a circular path of 300 meter. So I have 300 meters starting at the same point at the same time. So same point, same time. Speed of A is 5, speed of B is 3. So A at 5, B at 3. When will they meet for the first time? Given that they are running in the opposite direction, when will they meet again at the starting point? Okay, so they are running in opposite direction. So first time is opposite direction is nothing but 300 divided by sum of the speeds, which is 3 plus 5, 8. So 3 by 8 is 37.5 percentage. Hence, they meet for the first time at 37.5 seconds. Starting point is nothing but LCM. So 300 divided by 5, 300 divided by 3. So LCM of the fractions, LCM of the numerator by HCF of the denominator. So 300 is the numerator, HCF is 1. So 300 seconds they'll meet for the first time at the starting point. Hence 37.5 and 300 are the answers. So easy, direct, simple calculation, LCM or formula substitution. Okay. The next question. A and B run around a circular track of length 1200 meters at respective speeds of 15 meters per second and 8 meters per second. So circular track, I have 1200 respective speeds of 15 and circular track 1200, 15 and 8. So A and B starting from the same point. Okay. And at the same time traveling the same direction. So both are traveling in the same direction, clockwise or anti-clockwise. When will they meet each other? At the starting point for the first time. See, starting point for the first time, it doesn't matter whichever direction they travel. The required answer will be 1200. LCM of the numerator is 1200. HCF of the denominator 8, 15 HCF is 1. So after 1200 seconds, meters per second, they will meet. What is 1200 seconds? 1200 divided by 60 minutes, which is equivalent to 20 minutes. Hence choice D will be our answer. See, circular track, when they will meet, is all the questions are literal oral answers. So we are done with almost every question. We have discussed every concept. I have covered every concept in the given time and distance. Remember the only formula and the logic, how every formula is altered and how what you should know when trains opposite direction, same direction, what is the speed, should I add, should I subtract, why, you know the logic. So the additional questions, I'm leaving it to you. Just try these questions, nothing difficult. It will be the same concept, just the numbers are changed, some slightly addition, the wordings are changed. So you can just try these questions and practice this chapter. It's one of the most interesting and actually it's important any competitive exam. It's not difficult. It might look difficult, it is actually not. Just practice the same questions again. You have the handout with you, take the exercise problems, do it without fail. So all the best, see you, bye bye. I'll see you in the next video. Thank you. Hello everyone. Welcome to the session. Today we'll be discussing